There we go. So this meeting is now being recorded. If you want to watch it later, you can. I'll post it up into YouTube, and then leave it there for a couple of weeks, and then probably delete it. But here we go. We are in section 3.3, which is titled Analyzing Graphs of Quadratic Functions. So we saw in earlier sections shifting graphs, and for example, we saw this, and this was on the exam as well. So we know that the square root of x, for example, looks like that, right? And if you had something like the square root of x plus 2, let's do this in a different color so I don't have to draw a bunch of different axes. But if I had something like the square root of x plus 2, you should know that that's a shift to the left by 2. So 1, 2, and that's over there. And then if I had something like, say, the square root of x plus 2, and then minus 2, that is not only a shift to the left by 2, but now also down by 2. So 1, 2, and it starts here, and it shifts like that, right? So these are things that we've already covered. We talked about this in previous sections. We're going to talk about it again, specifically when we're talking about quadratic functions. So that is to say, that's not what I want. We're going to look at stuff like, say, x minus 3 squared. Minus, say, plus 4, right? But again, based on what we've done in, I want to say chapter 2, I can't recall, but somewhere in there, we talked about shifting an x squared. And so if I look at what x squared looks like, x squared is just a parabola. It just looks like this. Sort of, right? But if I have, in this case, this x minus 3, the minus 3 inside the function of the square means that this thing ends up shifting to the right by 2. I'm sorry, not by 2, by 3, right? Because inside that parentheses, when it's plus or minus, you go opposite, left to right. And so this is a shift right by 3. And then this 4 is simply a shift up by 4. So I'm going to take that, what's green there, that x squared function, and move it to the right by 3. So 1, 2, 3, and then up by 4. 1, 2, 3, 4. And that's all I have to do. My new vertex, the very bottom of this parabola, starts there. And I just get the parabola over there now. Right? And so that's the idea behind this entire section is that right there, right? So we're going to formally write it as this. We'll write it as f of x equals, sometimes you'll have an a on the outside, so we'll have a times x minus h squared plus k. Right? This is the type of way that we want these to look at, like in this section, for graphing purposes, but also to be able to find some information about the actual graph itself, including its vertex, which is that very bottom point of a upward facing parabola, or the top of a downward facing parabola, right? So the function, this function here, is simply x squared, but with a vertex of h comma k, right? And a vertical stretch of a, right? So if a is If A is greater than 1, then it's a stretch, right? Right, it gets elongated. But if A is between 0 and 1, then it's a compression, right? If A is a half, then everything gets squished by a half. And so this is a compression. And then if A is negative, then it flips it, right? If it's a negative A, then all of that, instead of going up, it's going to flip down and go downwards. And so if A is less than 0, then this thing flips about the x-axis. There's a couple of other things that we need to know here. We would also say that the line x equals h is the axis of symmetry. So let's take a look at one. Let's graph one. Let me try to still a Cartesian coordinate here so that I don't have to keep drawing them because my drawings are terrible. Here's one. Oh, that's got stuff on it. There's one. Take a look at this. Oh, it disappeared on me. Okay, that's not helpful. Okay, where is it? There we go. All right, let's graph. This function f of x equals, let's say, 2 times x plus 3 squared, and then minus 2. So again, I should know, since it's a square, I'm essentially just dealing with a parabola, then I'm going to just move to the right place and then stretch, right? So I'm going to just plop in my thing. Ignore this little x over here. I don't know how to get rid of it. There. Zoop. Doesn't exist. So I really just want to take an x squared, right? So I'm going to do x squared in purple. That's just this guy right here. All right, to the best of my abilities, that's x squared, right? But I'm going to take this thing, this plus 3 is a shift to the left by 3. And then this minus 2 is a shift down by 2. And then this 2 in front here is just a stretch of 2, of a factor of 2. So I'm going to just move this left 3. So 1, 2, 3. And then down by 2 puts me 1, 2, right? And so for now, I've got this thing sitting right here. God, I'm bad at this. But everything then has to also be stretched by a factor of 2. So my final answer I'm going to do in red, this whole thing ends up being this green. Everywhere that I have, it gets stretched by a factor of 2, but from that vertex. So this point here, right here, doesn't move anywhere. The distance between this and this point here is a y value of 1, so it gets stretched by a factor of 2. And so this goes up to 2. And so from that vertex, I just take it and stretch it, and everything gets kind of thinned out in the middle. But it ends up looking like this. And so the red there, I mean, it looks terrible because I can't draw a great curve to save my life with this thing, but that's what it's going to look like, right? We have this little point right here is my vertex. And that happens at -3, -2. So my vertex is at -3, -2, which we could have just gathered from this. It's the opposite sign of what's inside there. So -3, and then the same sign there. Well, this is my x value. X is -3, and then the y value is -2. And that's my vertex. That's where this bottom point happens. Okay. So if I wanted to do that again without going through all of the stretching and the moving, then I can just say I know my vertex is at -3, -2, and so I'm just going to go straight to it. -3, -2. Again, ignore that x over there. And then it's just a parabola starting there that gets stretched by a factor of 2. And so it just becomes thin, and it looks like, I mean, that was better. It looks like this. It still kind of looks V-ish, but it looks more or less like this. Right? And so it should be an instant thing, right? Rather than having to think about it, throw something to the left, to the right, up, down, squish it, blah, blah, blah. All I have to do is know this is where I'm starting, stretch it, and I'm done. All right, let's try one here. F of x equals x squared plus 10x plus 23. And clearly this is not in that form, right? This is not in the same form that we just had it. What I want to do is turn this into a times x minus h squared plus k. How do I do that? You may not like the answer based on having had to do this the other day in class, but we're going to have to complete the square, right? So I'm going to do that. But again, it's not a hard process. I'm going to start with that middle number, 10, and I'm going to divide it by 2, and that's 5, right? I'm going to keep this in mind because I'm going to come back to it. I'm going to come back for this in a minute. But I'm going to take that 5 and square it, right? This 5, whatever you get after dividing that middle number by 2, square it, that's 25. That's what I want to have after my second term. So that is to say, I want this f of x to be x squared plus 10x plus 25. But I can't just add 25, but I can add 25 and subtract 25, and that's no problem, right? All I've done is added 25, subtracted 25, that's 0. I can add 0 all day long. But the reason I do that is because now those three terms make a perfect square trinomial, right? That is to say, when I factor these three, I'm going to get x plus something squared. And what is that something? It's always going to be that middle number divided by 2. It's that 5. So it's x plus 5, and then I just clean up this junk over here. Minus 25 plus 23 is minus 2, and I've got my function in that form. And the reason that I care about this is because now, if I want to graph this thing, it's easy to do so. All right. I know that I have a vertex at Again, it's always the opposite of the x input, so that's -5, and then -2. And so I know where this is. This thing starts right there. There's no multiplier, right? There's no a here. A is 1. So all I have to do is create a parabola. Hey, not terrible. It's probably the best one I've done. Still not great. But that's it. That's my parabola. It goes right there, and I am done, right? Are we all right with that? Questions on that? Okay. All right, let's take a look at another one then. Let's do f of x equals, let's say x squared over 2 minus 4x plus 8. Okay. Now we're gonna have to be careful here because my a is not 1. So when I complete the square, the very first thing I want to do is factor out that 1/2, but I want to factor it out of everything, right? So I'll factor out, this thing is the same thing as factor out the 1/2, and that leaves me now with just x squared. But remember, by factoring out the 1/2, that's like dividing each term by 1/2. So that is to say -4x gets divided by 1/2, right? Which is not 2, right? It's -4 divided by 1/2. But when you divide by a fraction, you're going to flip it and multiply, right? So this is -4 multiplied by 2. So I get -8x here, right? And if you think about it, how do I undo this factoring? Well, that's just a distribution. And so -1/2 times -8 equals -4. And so that's what undoes it. And that helps me know that I'm doing it right. And so then I get plus a 16 out of this guy, right? So be careful with these. Be careful when you're factoring out fractions, right? That when you factor out, it's a division, and dividing by fractions can be a little tricky that way. But it's this inside portion right here that I want to complete the square, right? So I'm still going to have this 1/2. I'm still going to have x squared. But I'm going to take this middle value, -8, and divide it by 2. That's -4. So I'm going to come back to this guy in a second, but -4 over 2, or sorry, not 2, -4 squared, after I square that thing, is 16. And so I want this to read as -8x and, oh, plus 16. It's already a perfect square because it's already there. So if that number's already there, don't add and subtract it because you're not going to do any good. This is already a perfect square. I'm good to just break it down. This ends up being 1/2 times x minus, because of this guy right here, -4 squared. And I don't need that bracket. So we kind of lucked out on the completing the square here. It's just 1/2 times x minus 4 squared, which means, again, if you're shifting it, you just shift it to the right by 4, but you don't shift it up or down, right? And so if I want to graph it, I can. My vertex happens at 4, there's no y value over here, but that just means it's +0, right? So it's at 4, 0. So my vertex happens here. And I am compressed, right? So my stretch is a factor of 1/2, which means everything gets squished down by 1/2. And so it would then widen this out and give me kind of a fat. I'm so bad at this. Parabola like that. The axis of symmetry is at x equals 4. And that's just this line right here where everything on the left is just a mirror image of everything on the right. So this on the right keeps going up, and they should look the same. Good with that so far? Okay. Let's do one more here then. Let's take a look at this guy. Negative 2x squared, let's call this whatever, g of x, equals negative 2x squared plus 10x and minus 23 over 2. So it's already unpleasant, right? Because I have a fraction right from the get-go. But I will still go ahead and factor out that a term, and that a term is negative 2. And so I factor out negative 2. That leaves me with x squared minus 5x. And then factoring out a 2 here is the same as dividing by 2. And since the top isn't divisible by 2, this ends up being 23 over 4, right? And if you need to do it off to the side, take 23 halves, you're dividing it by 2, which is the same thing as 23 halves multiplying by 1/2, right? So you end up with 23 over 4. I want to complete the square, so I'm going to look at my middle number. That is negative 5. And I divide that by 2, but there's nothing to simplify here, so it's just negative 5 over 2. And I take that number and square it. And so that is 25 over 4. And that's the number I want after my x term. So I'm going to plug it in there, right? And so I have this negative 2 on the outside, x squared minus 5x. I want this plus 25 over 4. And since I added it, I'm also going to subtract it, minus 25 over 4. And then minus 23 over 4. And this is all still in parentheses, right? Don't lose your parentheses because we have to be careful with this. But these 3 terms are a perfect square trinomial with this is the come back to guy, right? I'll write this then as negative 2 times x minus 5 halves squared, right? You can always shortcut your factoring in when you're completing the perfect square trinomial. You can always shortcut it because it's going to be that number that gets divided by 2. But then I have all of this minus these 2 terms here that I need to add. They're both negative, so they end up being 48 over 4, right? And 48 over 4 is just, and it's negative 48 over 4. So it's 48 over 4, but that's negative 12. I feel like okay. There's an error in mine. It's an easy to fix error, but let me point it out to you here. When I divided when I factored out a negative here, that should have changed all of my signs. And so my negative x squared term should have gone positive. My positive x term went negative. This term here should have gone positive. So this here should be a positive, and therefore this is wrong, and this is wrong. Watch your signs, screw up your teachers too. But this in the green here is -2/4. And so this becomes -2/4. Still seems like there's something wrong here. Because I'm looking at it and this is an example from the book, and they came up with a different answer here. Still gonna get 1/2 out of this. I got 1. Oh, no, all right. All right, my bad. I'm just having a brain fart. No, we're good. Everything's right so far. All right, so the issue now at this point is that this is not exactly in the form, of where we wanted it to be. We want this to be in the form of a times x minus h squared and then plus k. But this little bit inside here, this -2/4, which I can simplify to 1/2, is stuck inside the brackets with that 2. And so what I'm going to do is take the 2, the -2, and I'll distribute it, and I'll multiply it here in front of the parentheses, but then I'll also multiply it here to that, and that'll get rid of my square brackets, but it'll leave the parentheses. And so to do that, then I've written this as -2 times x minus 5/2 squared. And then I'm multiplying my 2 to the -2/4. So that's -2 multiplied by -2/4. But that's the same as +4/4, and that's just 1. And so this is my function in that form. But again, the nice thing about this is it was a lot of work to get it into this form, but it saves us a lot of work when we're graphing. Because when I go to graph this thing, all I have to do is know that my vertex is at 5/2, right, from this guy, the opposite sign of that, and 1. And I know that I have a rotation, what is it called? I'm rotated about the x-axis. Because it's negative. And then I know I'm stretched by a factor of 2. So that's all I need to know. My vertex is at 5/2, which is 2.5, and +1. So like right there, that's a really big dot, but right there. Right. And then it's upside down because it's a -a. and it's stretched by a factor of 2. So it simply gets stretched, and becomes thin or becomes long in the y direction. And so I have something that looks like that. And again, my graphs are awful. If you want a better graph, the book does it, or any graphing calculator like on the internet will graph these and make them look half decent. But anyway, so that's that. That's the graph of that guy. But the biggest part in this section is to figure out the completing the squares, right? And then we can see here by the use of the quadratic formula that in the function for any function like this, the quadratic formula, if it's in this form, then our vertex is always going to end up being negative b over 2a. Right? And then the function evaluated at that point is going to be the y value of your vertex. So for example, if I have, let's say, that 2x squared minus 3x plus 8, and I want to find the vertex without going through all of that completing the squares stuff, I can then just say, well, negative b over 2a is negative of negative 3, or the opposite of negative 3, so that's 3, over 2 times a, but a is 2, so 2a is 4. And then if I evaluate the function at 3/4, right? So f of 3/4 is going to be 2 times 3/4 squared minus 3 times 3/4 and plus 8. And whatever I get out of that is going to be the y component of my vertex. So I'll just evaluate it. 3/4 squared is 9 over 16. That all gets multiplied by 2. Minus, I can multiply this. This just becomes 9 over 4. And then plus 8. Now if I simplify just a bit here, multiplying the 2 in here simplifies this to 9 over 8 minus 9 over 4 plus 8. And I'm just going to plop everything over 8s so that I can combine these. This becomes, well, this is already over 8. That's 9 over 8. Minus, to get this to be over 8, I'm going to multiply the top and bottom by 2. So that's minus 18 over 8. And then plus, I'm going to call the 8 8 over 1 and multiply top and bottom by 8. That would be 64 over 8. And so I have negative, combining these two, that gives me negative 9 over 8 plus 64 over 8 gives me 55 over 8. And that is then the y component, which wasn't terribly pleasant here, but would have been probably a little bit less pleasant to try to go through and complete the square on this particular problem. All right, that'll be it for today. That covers section 3.3. Do you have any questions for me on it? All right. If not, then I will see you guys on Monday. Thanks for being here. Thanks, you too.